Hello! This lecture is about the different characteristics of matter, some of which are about their physical appearance and give us some more inherent characteristics about that particular matter, and about their chemical properties, which can give some information about how reactive they are. So this would be more about reactivity, and this would be more about some descriptive property about its physical appearance or about an inherent characteristic. So you can see this compare and contrast chart will give you good information about these properties. I'm going to go ahead and go straight down to the examples. The examples down for physical property are boiling point, freezing point, melting point. And so these are all inherent or inherent characteristics about different matter. For example, water's freezing point is 0 degrees Celsius. Water's boiling point is 100 degrees Celsius. And its melting point is the same as its freezing point because it's just the opposite direction, solid to liquid or liquid to solid. And so these are inherent characteristics about water. Every different compound and element tend to have a wide range of inherent characteristics. However, boiling point and melting point are the only thing that you can use to identify them. You can also look at things like conductivity, color, malleability, which means the ability to flatten into a sheet, and ductility, which is the ability to draw out into a wire. And so different types of matter, specifically metals, are likely to have malleability and ductility and be conductive, whereas covalent compounds wouldn't have these properties. So the physical characteristics are related to its composition. So for example, like I said, metal versus non-metal, Nm is non-metal here. They're inherent characteristics and they can be observed without chemically changing that matter. So for chemical properties, to contrast the physical, these things have to actually be chemically changed in order to talk about its reactivity. So it describes the ability to be changed into another substance chemically. Things like flammability, reactivity, how quickly it decomposes and how it decomposes. Does it make a lot of gases or does it make something else? Is it acidic? You know, it tells us a little bit more about its pH. Is it an oxidizer, which means to react with oxygen? So these characteristics are more descriptive about how they react. Again, these properties are used to classify substances just like we were talking about previously in our video into pure substances and compounds. So to relate to the chemical and physical properties, we have chemical and physical changes. Delta here does mean change. It's a really quick way to write change. And so when we change the physical property, it might manifest into just an appearance change, so we can see a change in appearance. It might change its state of matter, like the melting point would be changing from solid to liquid. Its evaporation or boiling point would be changing from liquid to gas, so that's going to be changing the state of matter. It might just dissolve, and so it looks like it disappears, but like when you take sodium chloride and you add it in water, it just kind of makes a liquid combination. So it's combined together, but it's not chemically changed. It's just dispersed throughout water. If you sculpt something, so you take Play-Doh and you mash it, or if you just take something and make a mixture, well, that's still a physical combination. So the best example I can give you is water and food coloring. These things are generally reversible because there is no chemical change to the composition or structure. It's just a physical manifestation. Chemical changes means a reaction has occurred. And if a reaction has occurred, there are evidences that we can see or hear or feel or smell that show us that a chemical change has occurred. You should know these. These are definite ones you should know. So I'm going to skip down here first. Gas evolution is an evidence of chemical change. That generally means gas is made. So you can see carbon dioxide or oxygen or something, some steam, which is water, coming off the top of reaction. Combustion, maybe that means there's fire that you can see or feel. So I'm going to add down here as another characteristic is that you can feel the evidence of combustion, which is heat evolution. And heat isn't the only thing. It could also be cold or cool. Temperature change basically is what I mean by this. So if you see either of those, if you see a precipitate forming, and if you look back at some vocabulary, a precipitate is when you take a liquid and another liquid and you add them together and you make a solid. Generally, that's not expected, and so PPT is the simple way of writing precipitate, and we'll do an example of that. Decomposition generally means gases are being evolved, FYI, but those are generally the evidences of chemical changes. These are irreversible because once you go to make a product, generally, sometimes you cannot reverse the reaction to remake the reactant. So reactants yield to products, and that's what I mean. There is no reversible reaction in this case. Later on in our life there will be, but not right now. So an example of this would be whenever you have iron and oxygen, it oxidizes and it makes rust. Well, that's a chemical reaction because a new substance was formed. That new substance has its own inherent properties or new properties formed as well. So it's a lot more complex than just a physical change. The one that everyone generally gets mixed up is color change. Is it a chemical change or a physical change? We'll go into more depth about that. However, if it's a predictable color change, then I'm going to say it's physical. If it's an unpredictable or unpredicted color change, then it's chemical, because generally that unpredicted color change is because a new substance is formed and it just happens to be a different color, and so you wouldn't know that until you saw it. I'll give you some more information on that later. Lastly, with chemical changes, generally we will be writing equations to represent those changes, as you can kind of see in the example with our iron and oxygen yielding, so that's a little arrow, yielding to rust. Alright, so we have some pictures now that will show these. You can see that this is some corrosion and it looks like it's rusting. Well, you're right to say it's rust, it definitely is. And with that, we can say it's a chemical change. Light and heat given off here and here, those are chemical changes. Whenever you just melt some, or excuse me, freeze something liquid to solid, that's a physical change. But when you take one composition and you change it into another composition, that's a chemical change. You can see that that looks different than the reactants. Going back, you can see that there are these colors coming from this neon light sign. That's because electricity is now flowing through gases. Guess what the gas is? Neon. Neon's not just the color, it's the actual gas neon. And it's energizing it, which is going to be a change as well. And then our last slide here has just some additional changes that I didn't talk about initially, just to give you some more terms that you can use to describe your physical changes. You see bending, crushing, mixing, and cutting. Matter would be physical because it's just changing shape or form. And then fizzing, we'll think about what fizz and foam might include. That's probably gas evolution. So gases are being formed, which is causing that fizz and foam. And then the last bit will give you some information about what these might look like in a chemical reaction in the lab. So we do have a lab planned, and you will be seeing and working with the chemicals and deciding if you're seeing chemical or physical changes with these. Thank you.